So apparently I just feel like matching everything, so we're going to do another match for a couple of equations to graphs. This time, though, we have a general equation for a graph. And again, just to kind of refresh your memories on that, we have some coefficient ax plus some coefficient by plus a constant c equaling 0, and that is our general form. It doesn't really mean anything except general form typically in mathematics, especially at higher levels, it's just 0 on one side of the equation side. On one side. It's kind of like what general form kind of means. It's a very general equation. It doesn't really describe anything perfectly. It's got its pros and cons, but that's our general form. So let's go ahead and match. And there's a real beautiful thing that we can do with general form, and that is it's incredibly easy to get x and y intercepts. So in this case, what I'm going to do is I'm going to take both my equations, and what I choose to do in this case is I'm going to get the x and y intercepts for both of them. It's very easy for that to do. And I'm going to see, since there is such a well-defined x-intercept and a y-intercept for both of these graphs, I'm going to go ahead and do that just because I think that might lead us into getting our answer here. There's a lot of different ways that we can do this. We can always transform this into a y is equal to mx plus b and take a look at slope stuff as well, but I'm going to see if I can get the x-intercepts for both of these and the y-intercepts. So let's go x-intercept, and we're going to set y. Let's spell set right, hey? Set y equaling to 0. So we're going to write out my equation one more time, but this time, instead of writing y, I'm going to open a set of brackets and put 0 in, and continue on. Well, this is going to mean that 2x minus 6 is equal to 0. We're going to throw the 6 onto the other side, and we're going to get x is equal to 3. So we have an x-intercept, x-int at 3, 0. Perfect. I can do the same thing for that, for y, and I can just set my y-coordinate to be 0 at this point. Or I can set my x-coordinate to be at 0, sorry. So my y-int would be setting x to be 0. And we can go ahead and we can write down my equation again. We can have 2, open bracket, 0. And we can keep on going. Plus 3y minus 6 equals 0. And we're going to see that 3y is going to be equal to 6, and y is equal to 2, which means that I have a y-intercept at 0, 2. Well, just from this information alone, we know that this graph over here is going to correspond to the 2x plus 3y minus 6 equals 0, because we have my x-intercept at 3. And obviously this one's going to be the other one. But just for kind of argument's sake, what we can do here is we can also take our B graph, and what I'm going to do here is just kind of show a quick manipulation of how we can put this into y is equal to mx plus b. So what I'm going to do is I'm going to isolate my 3yx, my negative 3yx, and I'm going to throw over my 2x onto the other side, and I'm going to do the same thing with my 6 as well. Then I'm going to actually go ahead and just divide everything by negative 3. And look how I'm doing everything by it. So I could say that y is going to be equal to 2 over 3, double negative, plus 2. And this would be the y equals mx plus b, the slope-intercept form of that. And that would make sense because I have my y-intercept at 2, just like this equation's saying. And my slope between 2 points would be 2 and 3. I would be going backwards 1 to negative 3, and then I'm working my way down 1, 2. And this would give me a slope value on this graph. M is going to be equal to rise over run, negative 2 over negative 3. Hey, that's a positive slope, 2 over 3. And that is the same as my slope value over here and my y-intercept. So there's a lot of different ways that we can do this one. I just chose to do taking a look at an x-intercept and a y-intercept, but it was a pretty easy and a kind of a clear-cut decision on which graph is which. Making sure that you know how to manipulate these is always important, just because that is a useful tool in math and especially in all algebra. But really easy question, just another mix and match one.